So last stream, we started making a little library to handle command line arguments in a simple and easy fashion, because that seemed like a fun thing to do, and it seemed like a fun way to do metaprogramming. So the idea behind what we did is that if you're writing a new program, you just make a struct with whatever arguments that you handle, and then you just call parse arguments with that struct, and things happen. And then the values get filled in, and that works pretty well so far. So if we run args, which is the name of this little test program for this, which we do all this, then we print out the struct in the end, all our values end up in there. So this is great. My goal is to get this to the point where it could replace the command line argument processing that we had for the Sokoban game. It's almost there. It is not quite there. Can you ask a follow-on question about assets? Sure. Why not? Anyway, so you get back this struct right now. And this struct could have things set to default values or something. Like if you had a window resolution, I don't know, you could have that be set to like 1080 or something, who knows. But the thing is, you don't know yet if that's the default or if the user specified it in a command line option. So what I want to do is some fun metaprogramming where we generate a parallel struct to this. So right now we say, were we successful? Let's get the arguments. I also want to say like is set or something, and some variable that tells us which things were set. And what that would look like is, I don't know, like something like this, right? And then for every single thing in here, we would actually get back a Boolean that defaults to false, right? So it would look like this. Right? And so on. I'm not going to put all the members in, but you get the idea. And then we can use this for two purposes. One, like I was mentioning, we can tell the user that these things were set. But two, we could then use this struct to tell people or to detect when an argument is set twice and tell the user, oh, you accidentally set this argument twice. That's not a good idea. It's not allowed, right? So, of course, we don't know what this is, so this would have to get generated based on the user's input to this function. So let's just do that. Let's just do that first. And let's get rid of this for a second. We're not even going to try to make the new struct yet. The first step is just, let's print out what the string would be of that struct, right? So down here, remember when we were parsing arguments, we did this whole loop where we iterate over all the members and then we put them into a list, right? I mean, that's basically what we want to do. Except you can imagine different ways to go about this, right? One of our notes here is that we kind of want to statically forbid these situations so that if you make a mistake about putting an unhandled type in your argument struct, you get that feedback at compile time rather than runtime, right? And so we probably want this whole loop to happen at compile time. And what we're saying is we're going to put this loop at compile time anyway because we want to use this loop to generate that other struct. The question is, how exactly we want to do that, because like right now what we do is we put the members from the original struct, right? Each of these, there's a type info for it, and we put it in here, and then we iterate over that. But the thing is, we might not want a direct one-to-one mapping like that. So for example, you might want to be able to let people say dash language or like dash lang or something. So you might say alias lang, right? And then we kind of have two names for this thing. And so maybe we want to build a different array that just maps names to slots and could have a many-to-one mapping or something. You know what I mean? But I also feel like I don't want to worry about that yet. I kind of just want to do this one thing at a time. So even though, you know, we maybe want to move this whole loop to compile time, I'm just going to make a separate loop for now. But so that these loops don't get out of sync with each other, I'm going to like abstract this. I'm going to make a should skip member type info struct member, right? And if, well, return true, well, return true, return false. You could boil this down to a simpler, just return a Boolean expression, but I want to leave the option to easily expand this by putting more things, right? And then we're going to say if should skip member continue, right? So that's just going to go down here. Oh, we don't need this commented code anymore. We handled that. Okay, so great. That still works. I mean, well, let's run it. Still works. So now at compile time, well, no, actually, even still at runtime, like let's just build a string that contains all these lines. And I'm just gonna do it like this. I'm just gonna say, if we should skip it, continue. Otherwise, well, okay, I'm going to have a thing called a string builder, right? And then let me go to this, you know what I'm talking about. Where is it? Is it in? Yeah, it's in here. I don't remember where my files go. Anyway, string builder is a simple struct where, you know, it's got some buffer and you just kind of allocate more space as you use more. And we use this to, you know, dynamically do things. And we just got to call free buffers at the end, right? So we're going to go defer free buffers in the builder. We wouldn't have to do that if we set this to an arena allocator or something, but we are not doing that. So, well, we go over all the members, and we're just going to say, do we say add append? Oh, no. Oh, append. We're just going to say append to builder, and I'm just going to like indent, because why not? The name of the variable, a colon, equal false semicolon new line, right? And member.name, right? And then I'm going to say print that just to make it easy to see. And I'm going to say print members are this. And we say get a builder to string. Okay. So, screwed up. Wait, what? I did two things. Oh, I could, okay, this append is not, oh, we have a print to builder. Sorry. Append is just for individual strings. If you're doing like a more complicated format print, then you call it a different thing. All right. So here we go. We've got a string that's got all these struct members, and they're just set to false, and they have all the same names, and they're in the same order, and all of that. You dropped one of your favorite cups. That's terrible, dude. terrible. Okay. So now what? Well, instead of printing this string, we just want this string to be some code that we compile. And so let's do the following thing. We'll just make a type in here. We're going to say, what are we going to call this thing? We're going to call it an isSet, right? IsSet is going to be isSet of t. All right. And we're going to print the same place where we printed these members. Instead, we're going to say print isSet is. And instead of builder to string, right, we're just going to print this value, right? OK. So now the question is, what is this, right? Well, it's going to use this body text feature, or not body test, body text. And body text, we've demoed this before. It's on YouTube if you want to look, but it just says what follows is not the body of the struct, it's the code that generates the body of the struct, right? And what code is that? Well, it's this code that we just wrote. So right, we're going to do this, and it's a little dicey actually already because I mean, should we check for this error here or whatever? I have a feeling we're going to move a lot of this code over to here or into something that this calls to do the error checking. So we'll see. Anyway, so we get this info, and then we're not going to do this because that's for this stuff down here. We are going to do this, right? This stuff that we did, and we're going to say return builder to string. So hopefully I didn't forget anything there. This will actually, if you call this with something that's not a struct, you'll get a compile time error, but it'll be a little bit inscrutable. It'll say info.members doesn't exist because this type info would only return type info struct for a struct. For any other kind of type info, you would get something that doesn't have members. OK, so how many mistakes did we make? A non-constant declaration. What did I do? I don't know why it doesn't think that's constant. Oh, wait. It's been a while since I used this, so I might have changed the semantics of it. Let me just see. Oh, these are all for functions. So if I did something with structs, like this is weird. Like I shouldn't need to put this. I'll get a warning if I put this, but yeah, not required. This is interesting. It could be a compiler bug. It could be me being dumb. So what am I doing wrong? Besides not drinking enough Bengal spice. Well, let me do something dumb. That's slightly bad style. And we'll see what happens. All right. So it worked. I don't know why I have to do this exactly. So I think when we execute the body text, we don't mark the thing as constant, and this type info requires a constant. So I'm going to mark this as compiler bug. Why can't we do this? But it's okay because we could just cast the type to a type info anyway, especially because this runs at compile time. So like if you were running at runtime, there's the possibility that somebody might have turned on the option to strip type information. And then well, if you did that, you wouldn't be able to do any of the stuff that we were doing. But in such a case, you wouldn't be able to do the cast because the type would be just like an anonymous integer. But at compile time, there's no such thing as stripping type information, right? So anyway, so we returned this string, right? And now we have this. And this is not a string anymore. It's an actual data structure. And to prove that, we could do the following thing. I don't know. I mean, this will be stupid, but we'll say is set dot language is true, is set dot no vsync is true, right? So let's do that. And so you see that we were able to, whoops, sorry, in this one, no vsync language, right? So these are two parallel structs now. One is supplied by the user, and the other one gets generated at compile time based on what was supplied by the user. And then we just want to return this result t is set is an is set of t, right? And so we make this, and well, we're just going to return it. And then down in our use code, remember all that is just a library. So down here in our use code, we just say is set, right? And because we have type inference, right? Because we don't need to know what the type of this generated struct is, which is good because like because the struct gets made out of nothing, we like don't have any way to refer to it, right? But then once we get it, we could say type of is set or whatever, right? So, whoops, I didn't get that everywhere. We have multiple returns. Oh. Got to declare the thing before we use the thing. And another one. And another one. Let me just look for returns. Okay. There we go. Okay. So now, instead of printing it here, which is messy, we don't want to do that, but let's just print it out here. Success, args, message, print is set is the following thing. So now we're just going to print it out at the end of the program. There we go. So this is great. We've done some compile time stuff that very few programming languages can do. Right? And here's what makes it especially special. Like what if because this is again why I think this is a superior approach to most of the weird declarative things people do for metaprogramming, is we could do anything we want now. We could capitalize all of these. We could rot 13 you could do anything. We could change the first character, right? So here, because we're just generating an arbitrary string here, right? And so we're going to say name is copy string member.name, name 0 equals B, right? And so now, whoops, that's the old version. Wait, what? Why did we have B twice? Hold on, what? What? Are we adding an empty name? I don't think so. What am I doing wrong, people? Save me here. First, let's just do it easily here. Let's just put a B in front of everything. What? Sometimes my brain just doesn't work at all. Okay, so here we go. We have a B in front of everything. Oh, these are one character. X and Y are one character. So we changed the name of both of them to B, right? So here we go. Let's go if name.count is greater than 1, name sub 0 equals B. There we go. So now we have language and message and buys and bind 16 and all these things. So this is a very powerful approach, right? As long as you don't try to name two things B. Okay. So, and note how small the code is to do this, right? Like it's just that. And it's not weird code. It's not weird declarative language embedded in your imperative language code that's bizarre and hard to deal with. It's just regular frickin' code, right? I mean, we could do... I'm sure we have, like what? Do we have an uppercase? Yeah. Do this, right? Who cares? To underscore upper, not tauper. What is this, Unix? Given void, wait, what? Oh, it's in place. That's even better. It's in place, there we go. So now all our things are uppercase, right? You can do whatever you want. You can reverse the names. We don't want to reverse the names. We don't want them in uppercase, and we don't want them to have a B, because the whole point of this is that you can do stuff like the following thing, right? One of the reasons we wanted this is the following. In our usage code, we can start to check things. So we can say if is set dot windowed and is set dot full screen, right? Print error windowed and full screen are mutually exclusive. Please set only one or the other, right? So now, oh, except we can't do this yet because we don't set who is set yet. So let's do that. Let's test it first and show that that print statement never fires, right? So if I say dash windowed, and I'll try to sneak in dash full screen here, right? Then, oh, I'm not printing the thing anymore. Print args. There we go. So now, actually, in the case of Booleans, because we only set Booleans to true when arguments come in, we could have just set this, but we want other things. We want to check like, oh, you set size, but you also set full screen, and those are mutually incompatible or whatever, right? That's why we're making this is set thing, because, yeah. So, and you might say, well, why don't you make a mutually exclusive option in the thinger, in the library? And it's like, you could. That might be a thing that you might consider doing. But people's applications can be arbitrarily complex, and you don't want to push all that complexity into the core library. You want to find a place to split it where the complexity can stay in the user code, and the core library can be useful but still simple, right? This is a thing that we're not very good at right now. Over time, basically all libraries just grow grosser and more complicated. And we need to stop that. Like as a discipline, we need to We need to draw the line, as Captain Picard said. Don't fall into the trap of generating your manuals from your arguments package. They all suck. I agree with that. We do have a thing that prints like summaries of what's all the code in this module, and like, you know, what are the functions and what are all the arguments and stuff, kind of like Autodoc and stuff. But I refuse to let people call it documentation because it's not documentation. Like, I agree, auto-generated documentation is terrible, right? However, also in a language like this that doesn't have header files, sometimes you want an easy way just to know what's in there, right? So it's different things, I guess. Okay, anyway, let's set this. And so for now, we're gonna, I think we are eventually gonna wanna generate this ancillary array that has multiple, like a different mapping instead of just using these members, because we're about to do something slightly gross, right? And that slightly gross thing is the following. We want a simple way to put bytes in. And we know that these indices are the same in this members array as the other member array. So we're just going to cast to a pointer to U8 and just stuff it, or pointer to bool, I guess, and just stuff it. We could actually, when we generate the struct, make it a union between an array and not. Maybe that's better. But that also generates ickiness that the user can see. So maybe we don't do that. Or we could make a union ourselves. Nah, not worth it. Let's just do this. We'll put a correctness warning in there. Anyway, so when we have these members, all right, we're going to say okay, if we get the argument, we do something. Otherwise, we don't. What do? We're going to say bool pointer is bool base plus it index. Warning, unbounded array, unbounded memory write potential. Because, yeah. And then we're going to say if this means it was already set, right? Otherwise, you set it, right? Well, what happens if it was already set? We report an error. We say report error argument whatever was given multiple times. State.name. All right. Okay, well, what's bool base? Bool base is set, the address of is set. All right. Okay. Hey, look, our error popped up. Windowed and full screen. Oh, we're also indexing a nil value, everybody. Congratulations to us. But windowed and full screen are mutually exclusive. Please only set one or the other. How? Oh, we tested both because I didn't realize that we had two windowed, but we do. So we say windowed was given multiple times. Oh, we're not setting success to false in that case. We should. Right? We should fail if this happens. Anyway, let's try the multiple times with y 17.3. So now we've got two float values instead of two bool values, right? Argument y was given multiple times, so that's good. I'm just going to have to open a new shell here. I mean, we really enjoy indexing a nil value, but yeah, no. Of course, now I have to copy and paste from the other shell. What we've been doing. Okay. Let's close this one. Wait, did I close the wrong one? No, okay. It's just, we've got so many indexing nil values, I don't even know what's going on. Is success still true even after I changed it? What do you mean? Anyway, okay, so now let's print out in our user code. I'm going to say print is set is whatever that is. So there we go. So what was set? Well, language was set, unsigned 8 was set, x and y were set, and windowed was set. Language, windowed, unsigned 8, x, y. And y was twice. So that's pretty cool. That's some pretty handy metaprogramming. Commander issue fixed April 19th. Yes, but newer versions of Commander just don't even work. Like, I've tried to change the font size and it stops rendering correctly and stuff. So this one, I can at least type things and they go into the console and I can see the result, which is more than I can say for the newer versions of Commander that I downloaded recently. Yeah. This is what happens when you build software by layering stuff on top of stuff on top of stuff. Nobody knows how anything works, and then you can't make the software function correctly. And yet, this is apparently the best console that I can find. So if that doesn't tell you that the world of technology is decaying, I don't know what is. Is it better for a library to print if there's an error or pass a variable bitwise to the consumer? Well, here's the thing. We log an error right now. And so you could override the logger to not print anything before calling this. And the language is structured to let you do that. The thing is, you wouldn't really then get, you would, in the current way it's written, you would have to parse the strings to know what the error was if you wanted structured information about what the error was. But so these print statements that we're doing down here, these are just our sloppy user code that we don't care about, right? So up here, we're using this report error, right? My alarm's going off. We're using this report error, and this report error is just calls log print, and that just goes to the logger. And we can redirect that if we want. How is command line argument parsing metaprogramming? There is somebody who just dropped into the stream in less than 5 minutes ago. Okay, so, well, we did this. we did this. Okay. So now let's start thinking about the structure of what we've done here a little bit. I think that let's try moving this stuff into the isSet thing that we just generated, right? Or maybe we do something slightly different. I'm wondering if it's better to put this into the generation of isSet, right? Or to have a third thing that we generate that is like, you know, the table for this stuff. And then we pass that to isSet. You know what I mean? Like, because somehow, you know, this is just generating a struct off on the side, which is nice and simple and compact. And so if we start adding a bunch more things into this and making it authoritative over what's allowed to happen, that's a little bit weird. So what we could do I don't remember if run directives can return arrays yet, which is silly of me. But I kind of want to make like a run directive that runs a thing that just does this at compile time, right? Based on this and makes an array. And initially that could, again, just be this members array. Except we definitely don't. So run directives, probably, they could only return literals. And this, is sort of a corner of compiler implementation that we haven't gone all the way into yet. Like, we don't really do struct literals yet because or maybe we kind of do, but it's not hooked up everywhere. Just because I never found them that important yet. And you got to have priorities in life. But like if I wanted to return an array of structs at compile time, I can't do that then because I haven't done that work in the compiler. Which is maybe what I would prefer to do here. Oh, well, what I can do, you know, it's interesting. Like, we really want to separate all our concerns cleanly. That's the main priority. And so whatever checks this doesn't like have to return anything necessarily. Right, so I could say run precheck members of t, right? All right, so let's do that. And this will be an improvement because, again, right now, these ideas about what's illegal would only get detected at runtime, and we're about to skip that to compile time, right? Okay, so precheck members. What is precheck members? Precheck members is $T is a type. Well, we say info is type info of t. This should automatically be a type info struct. Known to be. Oh, actually, no. It's not known there. Let's move this here too. Right, and then here we'll just say known to be type info struct if we passed precheck members. Right? Okay, great. So here we go. If it's not a struct, so we said we could do it using modify, but we're just going to run this, right? And we're just going to say, if it's not a struct, do we compiler report error? Yeah, so we can use this to report things and let's actually have a location to report. We want to put the calling site in. All right, so we're going to say compiler report error. Loc.filename, loc.line number, or loc.l0, I guess, loc.c0, and type passed arguments. To parse arguments is not a struct. Okay. And then that'll just cause the compiler to terminate when you say compiler report error. Okay. Let's actually comment this out for a second and make sure that works. So precheck members needs to pass a source code location, and that's going to be here. Oh no, we can't do that. Oh no. This is interesting. This is interesting. This is, okay. So this is a run directive. We're trying to do it at compile time. So we need to know this. In theory, we know this at compile time. But the way the compiler generates it right now, it's not really known to be constant. And so we actually can't get the location info yet. That is an interesting thing. We're going to have to beef up the compiler in some way to make this possible. I think. I might be being dumb. I might be being dumb. All right, so let's just not do the location yet, and we'll leave a note that, like, we would like to do this. We would like to do this. We're going to say file name is incomplete file name. Line number is 0. Character number is 0. Let's just put, these are shorter. And we're just going to do this. And we're going to put a big old comment here saying complete. We would like to get the information about the calling site over to here without the user needing, well, regardless of whether the user passes it explicitly, it won't work. However, the way caller location works right now, we don't generate a compile time literal, so the compiler doesn't know how to get it here. It thinks the value is only valid at runtime. We should fix this. It might be as simple as allowing you to use caller location in the body of a polymorphic procedure, or having something different. Instead of caller location, maybe that is just a runtime thing. Maybe instead of, oh no. Okay, this is actually interesting, because you could have a thing that says like the location from where this was polymorphed. I guess, yeah, okay. The thing is that things get deduplicated, but that means that if they succeed once, they would succeed. So, yeah. Maybe instead of trying to use caller location, we can have polymorph location usable anywhere in the procedure body, or something like that. Okay, so that note is left. So now, whoops, I didn't remove it from here. Oh, and now we're not using, we had this using type info tag up here, but we're not doing it here. All right. And we got to import compiler. Great. Great. Okay. So let's test this. So we're going to do this, but then we're also going to have Fusel is a no, we're just going to say we're just going to pass a type literal. We're just going to say parse arguments type 100 float, right? So that should trip that error at compile time, hopefully. Yeah. Type pass to parse arguments is not a struct, but we don't know the file name. I'm going to say incomplete. We don't provide the file name. Yet my sincerest apologies. And line number. Yeah. So we're going to have to fix that relatively soon. But this is good. So boom, error type pass to parse arguments is not a struct. Okay. Wouldn't you need to polymorph on the location parameter? The thing is, for this particular use case, no. Whether that's a good idea in general or whether it would be bad to not do that in general, I'm not sure, right? Polymorphing on the location parameter, I mean, that automatically prevents you from deduplicating, right? Which might be bad, but maybe not. Maybe for something like this, it doesn't matter because you're not going to parse arguments more than once. I don't know. But yeah, that's something that deserves some thought for sure. The reason I say no in this particular case is that the only time we would need the location info is if something didn't compile for that particular type, right? So if it did compile for that type, and we didn't polymorph the location info and the location info was wrong, that's fine because we only use it if we don't compile, which we did, so it's fine, right? But yes, in general, I'm not sure. Okay, so we're going to go over all the members. If we should skip it, we skip it. Otherwise, we do this stuff. And we are now detecting this at compile time. And we're going to replace these. So is that an actual? So this is just an error text. This is not a print function like. So we're going to tprint this. Right. Members is not a, I've still got my array. Oh, that's interesting. If we do this, yeah, so see, the problem is if we try to dereference this when this is wrong, this whole function has to compile before it runs. And so this error message happens before this. So our nice error message that we're trying to do here doesn't have a chance to happen. I mean, we can do something even sillier. We could do this. Ensure that this happens before other things in this procedure. So we're going to put a run in front of that. Oh. Right. Oh boy. So this is a different thing. See, we're starting to stress the metaprogramming and it's bringing up issues. So this check is meant to catch something different. This check is meant to catch, like, oh, you've got somehow a deadlock in your program where things are waiting on each other to complete. But this is a run that starts another run. And that should be legal, but it's not because I was dumb when I put in this prevention. So I'm not, this is a little bit convoluted, so I'm not going to do it anyway. Here's what we're going to do. We're going to separate it. so that we have a strict order. Like, we're going to do a run directive that checks the type of the base thing, completes, and then we do another one that checks the members, right? That is pretty straightforward. I honestly should be able to do that from in here. And I'm going to make a compiler bug note that I can't do that yet. All right. So anyway, we're going to do this here, except this using goes here. It's not worth doing a using, really. Okay, so let's put a little tag here called constant source code location, just to remind us of where this issue occurs. It also occurs here, right? Okay, so precheck, we're just going to precheck the type and then precheck the members, right? Bam, bam. Let's call it precheck base type. So this goes, it should complete, and then this goes, except we do need this type info here. Oh no, that doesn't work either, man. Right. It makes sense that it wouldn't. I'm not sure what's the best way to do this. I think I'm going to table it. I think the real comment is we need a better way to handle this situation. Oh, we could try the modify. This is interesting. This is interesting. All right. So let's put this back together again. See, I'm not in the habit of firing off lots of run directives, so like my brain doesn't jump to the right conclusions immediately. Like what happens there is like we fire off two different polymorphs that both like essentially in parallel happen, right? And so we get the error message from the other one before either of them runs, because both of them have to be done before this procedure tries to run. I just didn't think of that. All this work. See, we did the actual functionality very fast, and now we're just trying to do this one thing about making the error message good for something that people will probably never hit anyway. Well, not probably never, but it's rare. But we're just, this is a good way of putting the language semantics through their paces, figuring out what shouldn't be hard, but like is a little bit hard, and then we go think about how do we improve that, and then we come back later and improve it. So, so now we could try a modify. I haven't done a modify in a long time, dude. I don't even know if they work. So let's see. Let's just see if that, yeah, okay. So I just want to know, let's not even worry about this yet. I want to know if modifies like frickin' work. Okay. Undeclared identifier success. What we butchered some things. Oh, this is this whole thing. Okay. Yeah, we don't continue. We're not in a loop. We're just compiler reporting error. Yeah, that's all. All right. So the program still works. We haven't totally destroyed anything. Okay. We're going to say print in modify for type whatever. What happens there? in modify for type my arguments. Hey, it seems to kind of be working. Okay, so we're just going to put this up there. Right? And so let's see what happens. Oh, we've got this one. This same problem that we had before. Okay. All right. So it appears to compile and work. So now let's re-enable this with our mistake and see if we get improved handling. Yes. Error, type passed to parse arguments is not a struct. Okay. So this is a little bit... I kind of feel like using a modify here is a little bit of bigger guns than should be necessary. But I need to think about it because I don't, one reason why I wanted to do this metaprogramming thing is because I don't do this that often because we don't need it that often. And so I want to start exploring new stuff and thinking about it. And so this is an interesting problem. So, okay, so let me do a couple things here. Let's move this up to here and so this is highly conspicuous. We're going to just move these out of the scope so everyone could use the same definitions. Because the problem is, whoops. If we have multiple definitions of these, we run the danger of missing one later. So we're going to make them all the same thing. Okay. So these are going to go out to here. Okay, great. Type passed to parse arguments is not a struct. Oh, we at least get back to here, but we don't get all the way to the polymorph site, unfortunately. Although I think we're going to expand error mess. We might get this for free anyway, because I think it makes sense if you get an error down in the middle of thing to report the entire stack of like compile time polymorphs that are happening, and we just don't do that right now. So maybe if we did that, we wouldn't feel the need to pass a location down here. And that might be better anyway, because if the user doesn't have to worry about this, then that's good, probably. But for now, we'll leave these dummies in there. Okay, so then constant source code location, constant source code location. All right, it all works. But yeah, so the thing that I get to think about is, should we be able to sequence things when there are multiple run directives such that you're allowed to run the first one before the second one even compiles? And on the one hand, in cases like this, it seems like it would be simpler, right? On the other hand, that could get complicated and hard to predict and hard to think about in the general case. So I'm not sure. Are there any questions about what's going on here? I certainly have questions. What about $t type struct as a compiler feature? Yeah, so that would be a thing that would potentially catch this if it were done the right way. That seems a little bit more hard-coded than I would like, but I think there might be a way to make that general, yes. Right now that doesn't work because right now those type qualifiers are only you know, they're only for like struct inclusion, but we could broaden that. Okay. Anyway, so this is good though, because now our validation is like in a separate place. It's not pooping up the rest of the code. And oh, here we duplicated this for some reason. We don't want to do that. So it's more like this. So now we get compile time reporting on that. So let's fix that one, the dumb mistake that people are unlikely to make anyway. But let's introduce a different one. Like we said, arrays of undetermined size are not valid because we don't know what would go in them, right? So let's try, hey man is an expandable array of strings, right? So that should also generate a compile time error now. Ta-da. Hey man is of undetermined size. Let's say is an array of undetermined size. And then we could, instead of that, it could be a string S32, right? A relative pointer string. Hey man has a relative pointer. This is not permitted. Awesome. So we are doing compile time checking for errors, which is always better than runtime checking if you can do, well, always is a strong word, but yeah. Can I give a quick overview of what modify is doing? The very quick, I mean, there's 2 hours of YouTube videos about this feature, at least. But basically, if you have a polymorphic procedure, one of the problems that you have in languages that have template style things or polymorph style things is you end up generating way more copies of the procedure than you wanted, right? So like, say you had something that operates on an integer, and you don't really care what type of integer it is, but somebody calls it with a 32-bit integer, somebody calls it with a 64-bit integer, signed, unsigned, whatever. If you just make a different polymorph of this for each type, then you could be sad really fast. And then what happens if there's 3 integers, right? And you get many, many combinations. So what modify is about is you can change these input variables to be whatever type that you want. So even though t is constant here, I could actually assign to it in this code. We don't want to do that, actually. But while you're doing that pre-check where you could modify it, well, you also can just decide if you're happy with the value, right? So, yeah, that's all. Odin has where statements for procedures where you can check arbitrary constants, i.e. poly is proc whatever, where type is struct. Yeah, I mean, that's a thing. Like anything, yeah, I mean, just the proper way to handle that is the question, right? Type is struct is like a built-in compile time procedure. I don't think I would want it to be built-ins. I think I would want it to be arbitrary code. Do you have type bounds? If you mean, does the type system have the notion of bounds in it? The answer is no. No, it's a simpler type system than that. Okay. So we've done a lot of work here in the past hour. We still need to figure out what to do about this. I think my inclination is to fix incomplete report polymorph stack when from compiler report error so that we don't need dummy underscore star. I just don't want to go do compiler stuff right now. I want to stay in user space. Otherwise, we might do this right now. This might be it might be like a one-line change. Because I think I do have a function for reporting the polymorph context. It's just maybe not called from everywhere that it could be. Code generated based or depending on generated code could be very difficult to solve bugs with. Did you encounter it, and what insights do I have? I mean, look, if you have a powerful feature, you need to not be insane, right? You need to value simplicity. So yes, you could make a really big mess with compile time execution. Just don't do that. Don't do it. You need to have like restraint, and you need to value understandability. Okay. So that was one structural thing that we wanted to do. And now that we've moved that out and we've got this should skip, we kind of don't need this loop. We can just go over info.members down here, right? So I think we can do this, and we can just probably unnecessary. Well, I mean, the question is this a placeholder? I think it is. Okay, let me just say this for right now. Right now, there is not much point in making this separate copy of members, but later we probably want further processing in the case of aliases to the same command line argument. So it may make sense to operate on a processed array instead. So yeah, but we don't ever fail here now, so we don't need this, and we can move this declaration of success, I don't know, down there, and like this can go here, and this can go there. I don't know. Okay. So that's a little cleaner. So now what is the question? We could do some of these other things. We could do this, like, so this success thing might be more complicated than we really need. Let's take a look at that, right? So like, we want to return success, but then, you know, we made this variable yesterday before we made this parsing state. And like, we do member success. Like here, we don't really need a separate success variable. We could just check state.success if it was on the state. And that would remove some complications, I guess. But the real question is down in handle one argument, right? Because that's where I was feeling like that's where I was feeling like things were a little weird. Maybe they're not. Maybe it's fine. I mean, it's just kind of not clear to me whether there's an advantage to putting the success on state or not. Like here it's explicit and we return it. I think we would save like a few lines, like we wouldn't have to do these because instead of returning a bool, this would just set success to false. But that also might destroy information in a way that we don't like later. So I'm just going to leave it for now. I'm not going to do that. But what we can do is return unnamed arguments. All right. So one thing that happens right now. So we're going to parse arguments, and we're going to say allow unnamed arguments. And we're going to default that to true. Right? So we're going to return the success, the result value of your type, the is set. At some point when we start having too many return values, I start worrying, but we'll see. And then free arguments, I don't know. I don't know what it should be called. Is there a term for this? Like, these are just like the things that don't have options before them. Right? Okay. All right, so we've got free argument, lone arguments. No, this information in chat is a little bit wrong. There's a bytecode interpreter. It always runs regardless of the backend. That's not the backend. There are two backends, but the bytecode interpreter and bytecode system is before both of them, actually. I don't know what to call this. Is it both interpreted and compiled? Yes, except that the philosophy is that you don't ship interpreted code, right? It's not really made to run in interpreted mode in a shipping thing. That's just more for at compile time. No, there was a C backend at one point, but it's gone now. It's been removed. Let's call it, I mean, like free arguments is fine, but then I'm using free for memory and whatever. Well, if someone thinks of a better name. Okay. So if we find a thing, if allow free arguments, then array add free arguments arg. I don't remember. That's okay. Okay. Else, we report an error. Now the problem is we have to frickin' return free arguments all the time. That's fine. We only have like 4 return points. Oh, we only have 2? Here. I guess the multiple was further down. Okay. Oh yeah, because we used to have more returns because we were detecting those error cases at runtime, but now we're detecting them at compile time. So, all right. Hey man is a relative pointer. We don't want hey man anymore. Sorry, man. All right. Y was given multiple times still. Okay, what are we even doing? Oh, we're testing the free arguments. So now we should get some free arguments. Okay. So let's take our second y out. First y. Okay. We don't have any free arguments, so we're not printing anything, but we could add some. We could say food, etc. Mati. We broke something. Oh, because, okay. Yeah. So we added it, but then we continued on the code path, right? We actually want to advance the argument cursor because we went in advanced by the first character and like tried to match that against the name and all that, which is not what we want. All right. Yeah. Okay. So now we have our free arguments. At some point, you wonder if this is more complicated than people want to think about. So maybe there's a better way to return all this information. I don't know. But there you have it. And we could say we do not allow free arguments, in which case argument 10 does not start with a dash. Probably could come up with a better error message for that eventually. So good. Bam. So now the question is, do we do the dash dash thing? What do people think about the dash dash thing? Because everything else here is grittier, like implementation details, or maybe enums. I don't know about enums. It's questionable, but this one is like a thing that some programs do, right? But maybe the right way to handle this is to pre-detect it anyway, you know? Like maybe if you're the dash dash kind of program, you just want to search for dash dash first and then pass the subset of the arguments to the thing. You know what I'm saying? You like only single dash and single character arguments. That really doesn't, I hate single character arguments because I don't want to remember 27 characters for your silly program. definitely should handle dash dash. I don't know, like it's kind of a niche thing, right? It's like a thing that only a small number of, like only programs that launch other programs really use it, right? Or is there a different case in which it's used? Someone want to clue me in on that? Almost all Linux commands use double dash. They do? For what? Way back in the day, when I was not an old man, I didn't think they did. But maybe I'm forgetting something. Oh, you mean use double dash for the words. That's not what I'm talking about. That's just a backward compatibility bullcrap thing for the fact that there's commands with single characters. We're deprecating the whole single character thing because that's just not what this library is about. When I say dash dash, do we handle dash dash? I mean, I could see a case for allowing handling dash dash that you guys are talking about just as an option, but I wouldn't add all the single character stuff or whatever. We might do that. But no, the dash dash I'm talking about here is the argument splitting dash dash, where you have double dash and then nothing, right? You know what I'm saying? It's a different thing. Like the cursed double dash. Yeah, no, thank you. Wait, why? Why is it cursed? You need double dash for grep if you want to literally search for double dash. Yeah. But also, I feel like people could sort of, I don't know. Windows style. Okay, here let's do the other kind of double dash, just because for compatibility. We're gonna have an allow double dash option. So we're gonna say allow double dash. And that's going to default to false because, like I said, you know, my opinion is that we have to clean things up, right? Computers have to get simpler or we're in trouble. Or even if we don't end up, you know, Jengaing everything, we'll be paying very large costs that we would rather not pay. The future can be much better if we're not paying stupid costs all the time. So this is going to be in here for compatibility, and we'll explain it down here. Allow double dash is here for people who want to make programs compatible with all the new style Linux stuff that uses command line options. Let's do this. Uses arguments like this, but it's not recommended since we don't support single character options here. Double dash in this way doesn't make sense, really, for new things. Okay, so if we allow free arguments, or no, okay, if allow double dash and, well, okay, here's the thing. Let's make it require double dash, because there's this weird thing like, what if you say allow double dash and they only put single dash, right? Like what what's the deal there? I think we're just going to make the mode for right now require double dash. Right. So if we require double dash, which way should I do this? Right? So we're just going to reduce it to the single dash. Okay. Okay, wait. I don't know if there's a way to simplify this, because we want to say the right message. We want to say double dash down here, and let's just write it. Okay. Is argument is dashed. My hopes are dashed. So that tells us if it's dashed, right? So now if we require double dash, we'll just have a separate error message in here. Okay. Does not start with a double dash. Oh, wait. Like what? I don't think we want to say you can't have a single dash, because like someone might want to let you have a single dash. You know what I mean? So I think it's actually, we do this. Right. So it's either double dash. Oh, by the way, it might be a single character. It might be, you could in theory have a 0 character argument, I guess. Okay, so if it's dashed, not dashed, I mean. If we allow free arguments, we add it as a free argument. Otherwise, like that. That's the simplest. See, this is why I don't like adding complex, like things get complicated for stupid, simple reasons. Okay, so that's fine. If I say require double dash is true, now these are all free arguments because they don't have double dash, right? And nothing is set, and no value comes through. But then if I go dash dash y, then oh, okay, we forgot. Okay, we forgot. Here's where we skip this. One plus. That's where we use the fact that cast from bool to int is well defined, bro. Okay. So now we got y. It's minus 69105. And so now if we don't permit free arguments, what is it called? Allow free arguments is false, then it'll complain. Argument 1 does not start with double dash. So that's something. Can you do code coverage? We haven't done it yet. In theory, so, we have compile time modification of your entire program that you could do. So you could easily have a library that your compile time metaprogram calls that injects little, what do you call it? Accounting snippets that says, hey, we entered this procedure or whatever, or this block, or whatever granularity you want to test coverage. And then do that. It's the same sort of as writing a profiler, we just haven't done it. That's scary. Maybe you should just advance in the if. Is there a better place to put it? I didn't see one. It's not really scary. It's only scary if you're used to C. Okay. This is not actually scary. This is well defined. But it is a little bit funny. I agree. The thing is, this is we don't want to advance in here because we still want the full string for here. And we can't advance in here because this is if we're not going to look up the argument, right? Now we could make a variable up here called number of characters to advance, but that's like overkill. Do I have candies prepared at my disposal for the kids who knocks on the door? I live in an apartment building where there aren't any kids, so I don't have that issue. It's also not Halloween for me. That's tomorrow. I spent 12 hours straight coding. Wow. I mean, to be fair, if you actually work hard at programming for 12 hours, you could get pretty tired. But it's not like I haven't done that many times. Also, San Francisco doesn't have kids. It's true. There's a little bit of kids here. Is it legal to write exclamation point, exclamation point? It isn't currently. So we're already bumping up across like a barrier that I'm trying to decide about, which is just, if you try to make your library handle all kinds of stuff, Like if you try to make it handle whatever you think people might want to do, which is what people have been taught is the right thing. The problem is your library ceases to be small and simple, and that's bad because then people who want to go read it later aren't going to understand what's going on. It's just going to be all this stuff, right? Like right now, already this is a little bit big. It's 400 lines, you know, which is maybe enough. I mean, it's probably going to grow for whatever reason a little bit later, but we'd like to keep the growth down, right? Because, you know, again, the hope is we can build systems where people actually understand what's in their program. And the more that you make everything into a giant thing that handles all kinds of cases, the less that you have that. And so the approach that I would rather do is something like, look, this is the base simple version of this library. It is true that it doesn't do things that a certain percentage of people may want to do, right? It doesn't do things that a certain percentage of people may want to do. If those people want to do those things, they can just copy it and modify it, in my opinion, rather than just building ever increasing complexity into the core thing, right? So this is a thing people don't quite, and by people, I mean all of the society of programmers doesn't quite understand, is you're not really building an increasingly valuable asset as you put more functionality in. You're building something that's kind of starting to decay already. Because as soon as people aren't sweeping all the sidewalks every day, it starts to decay, if you get what I mean. So, we're already in that territory with this little library here. I'm glad you appreciate the videos. I don't tend to have recommendations for books and stuff. What does advanced do? It just skips the first characters of a string, you know. Oh, you assumed not was asking about bool cast. Oh, well, good point. Not would not give you an integer. Okay, so the reason you do not in C and C++ is because your bool value is not guaranteed to be 0 or 1, right? Except if you say not, I think it is guaranteed to be 0 or 1. Maybe. I'm not actually sure about that. You could do that here, but it wouldn't matter. And anyway, you'd still have a Boolean at the end of that. Like you still have to cast it to an integer. Because it's not legal to add a bool to an integer because we're strongly typed. Would it be simpler if you packed the myarg struct in a predefined parseargs struct that you can return instead of the tuple return? I'm not sure it would be better. I'm just not used to having functions with many arguments and many return values. Yeah, I mean, I'm not sure. Like once we get up to about 4 return values, it starts feeling like a lot to me. Like 3, I'm like, okay. But by the time you're at 4, yeah, I don't know, right? Would I want to pack this in with the other things? Maybe not, because the reason is that now you have a new polymorphic type that you wouldn't have had to have otherwise, and that seems like complexity that I'd like to avoid. Because that type can't be defined in advance, right? It would have to be a new thing called parse arguments result of t. And then it would have fields that have all these things. And you could definitely do that. It's just, it seems a little more complicated to me and doesn't add anything. But I could also see reversing that decision later and doing it that way. Array as arg, is it possible? I don't understand the question. You mean as an argument to a function? Of course, yes. is 4 the current limit? No, I mean, I have some functions with more return values than that. It's just, there's definitely at some point where I turn things into a struct. Like by 7, I definitely turn it into a struct. But by 4 or something, like, there's other ergonomic factors, though. Part of it is what happens when you're writing the procedure. So, here I have 2 return points in this procedure. We used to have more. And you have to, like, return all of these things. And the reason is these things that we're returning, like for fail states, you're usually fine if you return defaults for all of these, right? Because like, if success is false, maybe you shouldn't care about these. Although maybe you do. Maybe you care about what was set before we failed or whatever. I don't know. But for something like this, what I'm trying to say is, we have default return values in the language, right? So you could, like, your return values could be simpler, and then you could tack more things on the end. And as long as they have default values, you don't have to return them, right? And so your fail cases don't need to think about that. That works really well when they're like integers or floats or strings or something. But if it's like an array, I mean, I could default that to an array literal, I guess. I've never tried that. I'd actually, that's kind of asking for a compiler bug simply because I've never tried it. It might work. But like this, we would have to have some expression that says equals default of the thing, or like there's no way to put a default value on this without making a procedure, a polymorphic procedure that returns this, a default value of this type, and then run directiving that. And then, like I said, I don't think that we handle struct returns from run right now. So like, there's just some things that make it less nice ergonomically than it could be. Does this language have goto? It doesn't currently. We haven't ever needed it. We probably will add it at some point, but we don't currently have goto. Yeah, it's definitely a thing that you get used to multiple return values. I like having them. Definitely 2 values or even 3 values feels totally comfortable to me. But at some point it's like, oh, that's a lot, man. Also with arguments though, right? And that's the same in C++. Like once I get, I mean, it depends on the function and what it's like, but if I get around 8 or 9 arguments and they're all like different things, like if you have 8 or 9 arguments, but it's 4 positions and 4 UVs or whatever, that's fine. But if it's like 8 or 9 arguments and it's just all different stuff, I start feeling like, let me just pack these into a struct and pass the struct, Do you use any goto in the C++ code? I don't think so. Let's see. Like we have variables with the word goto in them and bytecode instructions, but that makes it hard to maybe search for, but oh, there's a goto. That wasn't me who added that. Ignacio added it. I don't think I like. Why? You're inside a while loop. Oh, because break. The only reason we need this is because break would break from a switch statement instead of the frickin' loop. This is just a flaw in C++, right? That you overload the keyword for both things and sometimes you want them both. The structured programming way of doing that is you're supposed to like maybe set a we're done variable, right? And check it here. But
I mean, anything that, this is in the parser, which we want to be fast, so I don't know. Break doesn't go by scope. Well, the switch is inside the loop. That's the point. It does go by scope. But we want to break from the loop, not the switch, right? And there's no way to do that in C++. It's funny, there's multiple problems here. First of all, the fact that you need to break from a frickin' switch in the first place, which was a giant mistake, right? Secondly, the fact that you can't name what you're breaking out of to resolve that ambiguity. At least 2 levels of thing wrong. Breaker 1-9er. Okay, so I think I'm going to warm up some water. We'll see if there's any questions. And if there aren't, we're going to do like the final awesome step, which is we're going to actively factor this into the module, which should be pretty easy. And then we're going to use it in the Sokoban game. Because like I said, well, I didn't say, but this whole file isn't even checked in. If my computer had crashed last night and erased the hard drive, I would have had to watch the VOD and type all this over. So on topic questions while I heat up some more liquid, and then we can do the last step. Why the hate for single character flags? Because maybe the namespace for math isn't math. Why does that matter? What is the best reason for compile time code execution? Well, everything we did today would not be possible without compile time code execution. Just go back and watch this stream if you missed it. Like how, explain to me how to do this without compile time code execution. Did I test this on Linux? No. We do have the compiler running on Linux, and there's not really anything about this that should be different. Like previously, I believe we have made sure that the command lines passed to the program are the same. Although there is the funny question about argument quotation and stuff, which is what this is there for. So we might look into that later. Will I be at Handmade Seattle? That is unknown at this time. It is unknown. Will this streams and yesterdays be on YouTube? Yes, hopefully. Unless something terrible happens. Okay, what should we call the module that does this? I was thinking like command line, but that might be too general. Could say command line arguments, but then people might never use it because it's too much typing. What is a good use for the feature you're implementing right now? Well, it's just so if you make a program and you want to have command line arguments, you could do it very easily without having to do weird stuff. That's what. Have we found any bugs or weirdnesses when using LLVM as our backend? Not really, just that it's slow. Command line arguments factory strategy manager. Yes. Great idea. Do you plan on switching from LLVM and doing your own thing? We already do our own thing. It's just our backend doesn't optimize. The plan is that over time, so right now the use of LLVM is to generate fast code on the back end. Eventually the role would become more like targeting platforms that we don't have our own support for yet, you know. Okay, I'm just going to call it command line for now because I don't have a better idea. And we can rename it later if we want to. So I'm going to get all this stuff. And I'm going to go into modules, command line, single file. And this stuff is going to be in file scope. In fact, a lot of this is going to be in file scope. I'm going to want to document this a little bit. That's going to be a thing. And then everything down here is going to be scope file, I think. None of that is user level. All right. So did we save it? Nope. So first we want to see it not compile because it doesn't know what parse arguments is, right? So import command line. Ding, ding, ding. Ding, ding, ding. So that's great. Well, there we go. And then what? Well, let's make sure the game compiles. Let's go edit the game.
Okay, handle command line arguments. So see all this code? This gets to go away. Now this is the central mystery though, right? Like we're replacing this code with something that is actually more code. It does do more checking, and it allows future functionality to improve. And as we started adding more arguments, this code would get longer and longer, but there you go. Okay, so let's go import command line. And then what are we going to have? We're going to make a thing. It doesn't have to be called myArguments, but whatever. This is a struct. It's going to have language, which is a string, size, which is 2, I don't know, S32. Doesn't really matter. It's a resolution value, so it just has to be big enough. No vsync. Windowed is false. Full screen is false. That's all the arguments that we have, right? And so now we will say parse arguments, my arguments, success result is set. We're going to ignore the free arguments. Well, we'll just say false for now. Okay. So then we're probably, for now, just going to copy some stuff out of here. Result.language. Like, why do we have a different global if this is already in a global? Well, we probably don't need it, right? So maybe what we do is have this global be available, right? Instead of, yeah, you know what I'm saying, hopefully. Okay, so language, size, okay. So for that, we say so this is all now this is all very application specific, right? This is the kind of thing that you could try to shove into the library, but it's like it starts to be a really bad decision at some point, right? Okay. Okay. Actually, why? I guess he wanted to print both of these if they're both invalid. I don't know. All right. So again, these, it's like, well, I guess. Okay, and then remember this, we're going to use this. Okay, so if result.windowed graphics.windowed is true, if result.fullscreen graphics.windowed is false. So I have to say I do like this a lot better. Just as the user level experience, this is way better. Don't you think? I think. And in fact, like why, like here, let's do this. And then just do that, right? Like this is more about what the actual information and less about the cruft of manipulating arguments. Which may have had like there may have been like, you know, argument indexing bugs that we hadn't noticed yet in the version of the code that was here. Imagine one day that resolutions get so large that they don't fit in U32s anymore. Oh, come on, man. 4 billion pixels is enough for anyone. Size not declared. Oh, this is, right, this is result. You know what? Using result. I believe I forgot vsync. I did. And I've deleted whatever we set. Let's go look. Okay, here's all this code. Graphics.vsync equals false. All right. Great. Does it compile? Does it blend? It blends. First time. That's good, right? That's a good sign of a good API. I mean, we haven't run it yet. Run. No arguments. Oh, unknown language, whatever, resetting to English. We didn't do that before. Oh, because, okay, because we only, right, so if is set.language, the language string is language, right? We could do that down here all the time. Like here, we're kind of relying on the fact that these default to false. But we could say like if is set.windowed instead of the value. It doesn't matter for Booleans right now. All right. Great. Okay, so we did the same thing with size, right? So we didn't set the size. So we don't actually want to do any of this. So we want that. All right. So we didn't get it 100% correct the first time. But still. I think if I was used to using it, I probably would. Right now I'm in the middle of the big and hopefully final movement system rewrite. So there's tons of new movement bugs that didn't used to be in the game. We'll probably do a fun stream about that soon. But yeah, so like we have better code, I think. How straightforward would it be for different libraries to specify arguments independently and have them all collected into the arguments struct. So there's a little bit of a coordination problem there, right? Because how do you know that none of those different libraries happen to use the same name for an argument, right? And if they did, how do you resolve that? That's the actual annoying problem. Because you could definitely, instead of having a my arguments struct just like this, you could make one. So right now you would have to use a little bit of metaprogramming to make one that like flattens out all the members, because we don't do structs within structs right now. But we could allow that and just say that we do all the substructs. Something like that. But the question is, oh, well, if you do the substructs, you don't have a name conflict in the actual programming language, but you would have like, well, somebody said -x, and both these libraries want x, and I just picked the first one or something. That sounds bad. That would be a compile error, presumably. Yeah, I mean, definitely making a compile error is better than letting it be a silent bug. But you actually, the difference between writing some open source bullshit and like something that people could use is that you have to give people a reasonable way to solve the problem when that bug happens, right? Or when that conflict happens. Like, oh, I'm using two libraries that want the same option. I need to use both of the libraries, right? And both of those libraries want their variables to be named specific things. I mean, I guess I could make a struct with most of the same names, but like one different name, and then do the renaming or like cast it. I don't know. Maybe this particular case is not that bad. But the point is that you have to actually solve the problem, right? It's better to detect the problem and fail than to not detect the problem and silently fail. Like, it's way better to detect the problem and tell people there's a problem. But what you really need to do, the way you get work done in the world, is by solving the problem. And that's what a lot of people never do. So it could also be interesting for libraries to just declare global variables that are known to be arguments or something. Maybe. I mean, we definitely thought about having official module parameters. The thing is, I don't think you want those to go all the way out to the command line. Like, you want the program to be in control of what its command line is. You don't want like libraries that it links to be in charge of that. We actually do believe in safety here. I believe in safety, just not in the same way that the rest people do. I think more safety is good, especially if it's free. But freedom costs $1.09. You know what I mean? Like, if the safety is too expensive, then you can't afford it. Well, this is everything that I wanted to do. Like, it's been a very productive 5 hours of programming when you add these two streams together. Definitely, this isn't 100% of what we might do. We have some incompletes here. Oh, we got to document this. But we have some incompletes here. But that's okay. I don't feel the need to do all these right now. There are higher priority things now. I just wanted to see, like, the main point of this right now was, let's do this metaprogramming exercise and see if it works, see how it works, and whatever. And it worked. We had a couple of minor stumbling blocks, like little compiler bugs. I think we had 2 or 3 of them. That's good. That means we will fix those. I mean, it's not as good as never having had them, but it's good to find them before users find them. So this is a highly successful experiment as far as I'm concerned. You know, maybe people will end up actually using this command line library. Maybe they won't, but we will provide it and we'll see. And so the next stream that I want to do will be similar in that it's metaprogramming, but we'll start doing like SOA packing of, you know, structs and stuff. So that'll work the same way as what we did here, where we generate some type that's like the SOA of some other type. Can I do Fabian's job? Which Fabian? Do you mean Rad Games Tools Fabian or Game Engine Book Fabian? And the answer is probably not. Rad Game Tools Fabian? No, he knows lots of things I don't know. Could I train up to do his job with a long process of learning things? Maybe. But individuals are individuals, man. Like, and the way Rad works, it's a company made out of the individuals. It's a small company where each person works on a separate project. So like if I went to Rad, if like for some reason Fabian left and I went there, I wouldn't be doing Fabian's job. I would be like doing my job because that's the way that company works. Okay, let's document this. Is set is a compile time generated type, the purpose of which, or that, let's just say that conveniently tells you which of your options were set by the user as opposed to which still hold default values. You could test against a default value, but what if the user explicitly set the value to the same as your default and you need to know that? If you don't care whether a user explicitly set any value, you can ignore this. If you do care, just reference just use the fields of isSet that are the same name as the field. Just use the correspondingly named fields isSet. I'm going to have to reorder this a little bit. For example, if your arguments struct is arguments is a struct, hello is an int, I can't just do hello sailors forever. My is 3 string, friend is a float 64, right? Okay. then the generated is set will look like this. Oh, not enough spaces. And these fields will be set to true if the corresponding values in arguments were set by the user. That's maybe fine for now, right? That's kind of enough of an explanation. What is this 3-character goal? What does body text do? We explained that earlier in the stream. You could go watch the VOD. Anyway. That's pretty explanatory, right? Right. Is there anything I'm missing that I could explain better? So we were ranting about auto-generated documentation earlier. And this is exactly what I'm talking about. If you ran like Autodoc or some garbage on this, you wouldn't quite know these things that I'm explaining, right? This is actual documentation written by a human being telling you things that are meaningful. If we found a bug in LLVM, could we fix it? We might be able to, but we'd prefer to report it and have them fix it. Because they work on LLVM all the time, and we don't. I dropped a pistachio nut. That's what happens when you write documentation. You drop pistachio nuts. I don't believe in the 10-second rule. I am in the like 1 picosecond rule, man. All right, well, I'm not going to check in the game part of this yet because this movement system code is still in flight, and I believe it modifies some stuff in main where the argument parsing is. And I don't want to try to juggle a partial check-in. But I will check in the command line library, which is most of the code that we wrote, provided I didn't modify the heck out of the compiler, but I don't think that I have. What's this? Aha, that comment that we wrote. And that. Okay, great. add a module for nice parsing of command line arguments. You know what? I should just say we should document this better later, because I explained this, but I don't like explain the whole how you use this thing. Yeah, we'll do that later when we do a documentation pass. Uh-oh, out of date. Out of date. People are working on the compiler. It's terrible. All right. Let's make sure things still build. You never know. Why? Oh, was the game still running the whole time? All right. They do. Great. Bingo.